Okay, on the multi-body side of things, so multi-body was introduced back in Creo 7 last year around, primarily enabling advanced design workflows. So things like, simulation-based design, particularly where we can define like our fluid domain that we're working with if that's going to drive our model. Things like additive manufacturing, where we might be, printing multi-material parts, so we can define these different bodies to have different materials, or things like our generative topology optimization, okay, where we use bodies to define the different areas that the simulation or the simulation tool can decide this is where I'm going to do whatever I want in terms of generating material, and these are the areas that need to remain fixed. Imran will show a little bit more of this later with what's new in 8 on that side. So that was introduced back in 7. So some enhancements to multi-body stuff in Creo 8. So now the ability to, if you've got a multi-body part, to when you do your BOM report inside the Creo UI, inside the part UI, we can also then get the bodies appearing there. Now you could do that in drawing mode. That was there back in 7, but they've now made that available in the part mode. Okay. So you can also see them. You can also designate them here if you want to make those bodies exposed to wind chill. If you want to see them in that way, which we had in 7. Okay, so a bit more flexibility there in terms of working with those. The other one is around pattern references. So sometimes you might want to create, a body and then pattern that using all the normal pattern tools. So here we've got our sort of water channels through here. We've patterned them around, and then we might do a Boolean operation to now subtract all of those out. So that Boolean operation now recognizes and understands that that pattern has some parametric history. So if I go and change the number of instances of the pattern, the Boolean will update as I want to. Okay. Last one is around support callouts. So, if you have some defined annotations, if you're doing MBD related stuff, or you want to put them in the model to use with the drawing, so we can now create these callouts that can call parameters that are defined inside the body for your nodes. Sheet metal. Okay, I know there's plenty of you who do a lot of sheet metal stuff. So again, been lots of things through the Creo releases. In Creo 8, there's a few nice little things there. So there's now the multi-flat wall feature. Okay, so I can just go and pick as many references as I like as I build that flat wall. So it'll automatically handle sort of inner and outer corner definition, miter, do the cuts, whatever else I want. In terms of that mitering, I've got a whole bunch of options I can see here on the screen in terms of how I handle that geometry, what I want to do in terms of the corner, miter cuts and the like. We'll have a look at this in the demonstration. Okay, and a few other bits around other things like corner detection, handling bend relief for your flushed hems. Lightweight holes is now there inside sheet. Lightweight hole support, sorry, is there inside sheet metal. The multi-hole is there inside sheet metal as well. Okay, the last one there, because I know a lot of customers when this was introduced back in, I think, Creo 4, the flat simplified representation for your flat instance. So the ability to automatically create that as a simplified rep rather than as an instance, which would then be something else you might need to manage in Windchill. So you've now got a configuration option where you can define the default name for that flat simplified rep. Okay. So if you have a particular configuration that you use, you can define that in your config and have your flat pattern reps automatically use that naming convention. All right, the welding tool in Creo. Okay, so again, we've got a few customers that, quite a few of you who are using this. So the weld dashboard got a big overhaul along with, all of the other areas, grouping them together, basically making them match all of the tools that are there. A whole bunch of new icons there for things like showing, like it's saying here, groove and butt welds, having images that show that rather than just text to help explain it. So you've got all of your labels and everything there in the dashboard. Some more improvements around ISO fillet welds. Okay, so additional dimensioning schemes are now in there supported. Okay, some more options for your intermediate welding for both ISO standards. A bunch of options there for dimensioning schemes and working with your labels. Okay, again with the intermittent weld, some new options about that. There's a new panel that helps control that, and some more information around capturing those panels. And also on the side, the world preferences, when you're working with your world preferences in your dialog box, this was a little documentation thing where the picture in the preferences dialog box didn't match the pictures in the dashboard. So they've now made sure that they match up and they're consistent. Okay. And lastly, for if you're doing welding, if you're doing with MBD, model-based definition, so now we've got semantic reference control for weld symbols. So the idea is that, when you've got your weld symbol, now we can basically add in all of our semantic, so our surface references. So then when we pick on the MBD annotation, we can see all of those references that weld is highlighting or relevant to. All right, the warp feature. So one of our favorites was introduced way back in the wildfire days, the ability to sort of globally deform geometry. Okay, so still there. We've got customers who are still using it for certain clever, tricky things, twists and bends and stuff like that. Helps with these sort of weird manufacturing processes that you might use that are difficult to model. So the warp feature again has been overhauled to match up with all the dashboard layouts that are there inside. Okay, inseparable assemblies. Okay, so this is a new thing in 8. So the ability to basically take an assembly and define it as inseparable. So really the use case for this, and I know I've talked to plenty of you, particularly those working in Windchill, around this over the years. So and I might be working on my drill, for example, here, and I get a motor. Okay, so that's just a purchased item that we buy in, and so I might get maybe a native CAD file, or maybe more likely you get a step file of that motor. So you import that step file in, and it's an assembly, so you get an entire assembly structure inside your Creo model, which represents that motor. Great, I can put that in there, do all of my stuff, have my BOM and everything else. But really, from a business perspective, I don't care about all of the bits that are inside that motor. Okay, the business object, all we care about is the motor itself, right? Because that's what we purchase. We don't care about everything else inside, right? So what I can do inside Creo now is I can say, well, let's make that assembly an inseparable assembly. So what it does is it basically takes all of those components that are there inside that, the block, the bearing, everything else, and it now embeds them inside that assembly file. So if I create it, like if I bring in the step file, save it, make it inseparable and save it to disk, I've only got one .asm file stored on disk. Okay, that's all I'll see. I still see in the model tree all of the parts inside. I can open them up and work with them and do all that kind of stuff, but there's only one assembly file to work with. So for those of you who are working with Windchill as well, then the beauty of that is if you check in that assembly and you're creating WT parts for that, you only get one WT part for the assembly. Okay, so previously if you put that assembly in, you had your WT parts on, you get a WT part for all of the bits underneath as well. So there are techniques that you could use to turn that off, putting some parameters in and defining some rules in Windchill. But this makes that process much simpler, right? I don't care about all of the bits inside this in Windchill, right? All I care about is the engine. So let's just check the engine in as an inseparable assembly. And I've only got one Windchill part to worry about, one assembly file to worry about, nothing else, okay? That's still all supported there with repeat regions. Everything else is all there, but I can now make that inseparable. So I can basically take an existing assembly, I can convert that to inseparable, okay? So just by right click on that, I can convert it. I can also, if I really want to, take an inseparable assembly and convert it back. Okay, so that is an option if you need to do that for whatever reason. So you get the essentially like the old save as dialog box off an assembly, choose all the names of what you do. So you do get a warning dialog box that pops up when you do this. It gives you a little bit of stuff around reference handling and things like that. There's stuff like if you've gone and created, drawings of those individual components and worked, chosen references off that, those dimensions might turn purple depending on what you have. There's a few other things like if you make it inseparable, it's not supported by the tolerance analysis or the GD&T advisor tools, which we'll talk about in a little bit. Okay, so there are some impacts to working with inseparable, but as I said, from the examples I've seen over the years talking to people, it's really that sort of I'm dealing with imported data. I've been given a step file for something. It could be maybe like a PCB. it could be a motor, things like that, that I don't really care about all of the bits inside it, but that's what I've been given. I get this structure, which is great for visualization and everything else, but I just want to deal with that one assembly. So this is really what inseparable assemblies are all about. Another example, actually another good use case for this, because I know uh, some of you here today actually are working with motion skeletons. Okay, so a motion skeleton is a special skeleton that you can use for top-down design that has multiple components inside it with all of your mechanism connections. So you could just have like a bunch of curves and planes and sketches to really help you map out the complex motion of your design and then use those to drive the build of the geometry. So again, when you create a motion skeleton, it's like a special kind of assembly with all the bits that move relative to each other. So you can actually turn that motion skeleton into an inseparable assembly. It still it still understands all of the pin connections, so it'll still work as a mechanism, but you've only got the one motion skeleton part, assembly to deal with now, not all the individual parts inside that. Okay, another example of inseparable assemblies. Okay, so basically, there's also the ability if you want to, as you're creating brand new parts, you can actually create a brand new part as an embedded component inside an assembly. So maybe you up front, you design something that you know you don't actually want to be separated out, so you can define it as an inseparable part when you're doing that. Okay. The other thing as well, so from the data exchange side of things through Unite, if those tools have something that's equivalent to this, then Creo will understand that and maintain that relationship. So like the example of the SOLIDWORKS virtual assemblies, similar sort of thing.